Good evening, everyone. I'm Eros Nikitos. Very nice to see you here. I used to be a Lodovicos student back in the day, and I remember talking about cryobiology and how important it is to understand the significance and how biology works. Um, Now I'm working in Greece, in Athens, Greece, probably the busiest laboratory in Greece, performing more than 7,000 cycles per year and more than 5,000 frozen embryo replacements per year. So Lolo asked me to present this, to make this presentation regarding how we implemented, how we introduced this um, rapid elution protocols in our setup, and how we managed to implement fast protocols, as they mentioned it, in a very large scale. Sorry. This will not be just a protocol discussion. It's going to be a practical implementation story, as I said. Um, my own experience is that we adopted this direction early, and the most important lesson was that speed itself is not the innovation. The innovation is controlled simplification by reducing unnecessary manipulation in this setup. The reason this has become relevant is the change in the daily IVF workflow. We all know that warmings in very large IVF labs compete with media preparation, with fixing, with biopsy procedures. So we know that by increasing bench time, by decreasing bench time, it will be very, very beneficiary for the embryology team. The question is whether we can warm safely again and again during a busy morning and without adding any stress and timing errors of unnecessary exposure to suboptimal conditions. This is the clinical and operational context behind rapid vitrification and single-step elution. In practice, the bottleneck is not one thought. It's the whole morning. On high volume days, warming competes, as I said, with fixed biopsy and reassessment. Standard protocols are effective. We know that. We worked for many years and everything works well. We don't expect to have less than 95% survival rates in conventional warming protocols. But it requires time, multiple sequential steps, and more space for error. Our goal was not simply to finish faster. It was to reduce avoidable handling while preserving the safety controls that matter most. Traceability, validated temperature control, training operators, and continuous KPI monitoring would allow us to introduce these fast warming and fast vitrification protocols. Before discussing implementation, we need to define terms carefully. Rapid vitrification refers to shortening exposure during the vitrification process before plunging, with the aim of reducing cryoprotectant exposure and bench time. Single-step elution refers to simplifying the post-warming dilution and rehydration phase. And in the literature, similar concepts may be described as one-step warming, one-step rehydration, rapid dilution, or single-step elution. For a laboratory, SOP terminology is not cosmetic. The exact protocol must be defined: which medium, which carrier, which temperature we will keep on the bench, which volume, which timing, and which cell states for each protocol. Universality should never mean informal mixing of products. It should mean a validated, reproducible, and auditable protocol. The slide shows the practical difference. On the upper part of the slide, you can see the standard blastocyst warming protocol that we will follow. And on the bottom, you can see the single-step elution, which is much faster and much less error-prone. The time saving is substantial, around 90% of protocol time before culture recovery. And but the key message is that the simplification is procedural, not biological. The embryo still needs control of osmotic transition and careful post-warming assessment. The biological rationale is straightforward: reduce unnecessary exposure while maintaining control. Once warming begins, we want to remove intracellular cryoprotectants and allow rehydration and without prolonged manipulation. Shortened protocols can reduce time in cryoprotectants, reduce bench exposure, reduce transition between disease, and potentially reduce exposure to atmospheric oxygen. However, none of this replaces basic cryobiology. Temperature fidelity, osmotic control, and operator precision remain essential. In our implementation, the question was always, can we reduce handling without reducing control? And this is why rapid protocols must be introduced through validation and not just through enthusiasm. The recent clinical literature on one-step warming is reassuring. Zhang and colleagues reported live birth outcomes after single-step Blastus warming, showed excellent survival with no adverse in implantation, clinical pregnancy, live birth outcomes. Lieberman, as Lodo said, and colleagues reported large retrospective cohort with more than 95.5% survival in both standard and fast warming groups, with favorable pregnancy and ongoing pregnancy outcomes in the fast warming cohort. And the list goes on with much more publications supporting that fast warming is here to stay. This slide lists the safety barriers that we deliberately did not accelerate. Identity and witnessing were unchanged. Temperature setup, as I said before, was validated. Media and carrier compatibility was overchecked rather than assumed. Operators were signed off before independent practice. Rescue procedures were defined and in advance. And during the pilot trial of these procedures, we avoided edge cases like PGT, euploid embryo warming, or very precious embryos for, let's say, cases with one embryo left to the lady. So we try to avoid this. This was the governance message, and I want to emphasize that faster does not mean fewer safety barriers. The risk assessment belongs inside the laboratory, total quality management system, and the SOP should be clearly defined when it happens. What happens if timing, temperature, fidelity, confirmation of embryo behavior deviates from expectation. To conclude, single-step Elution is a genuine workflow innovation with reassuring Blastus warming data. Rapid vitrification is promising, but it should be validated separately by cell states, product, and carrier. Universality is the key strategic concept. It offers a way to simplify high-volume laboratories work and support cross-center material movement and reduce dependence on brand match choreography. This is what a lot of people previously mentioned as democratizing the process. But the implementation of the intervention, SOP, training, staff training, witnessing, temperature, as I said, and KPI surveillance determine whether the protocol becomes safer and calmer or simply faster. In our experience, when governance is present, time saved at the bench can translate into better workflow discipline. The core universality references as Parmigiani and colleagues reporting in 2018, 2022, and 25 and 26. Together, they support the transition from brand-led warming towards validated universal warming, post-warming dilution and single-step elution strategies. And I want to close by reminding to you that these papers provide a validation map, not a permission to bypass local governance. We need to validate also internally. We need to be sure before implementing in a large cohort of patients. And every laboratory must still define exact media carrier, temperature, timing, witnessing, and strategy for implementation in the future. Universality as a workflow architect. This is the concept. This is what we preach right now in universality. The real innovation is not only that thawing can be faster, but it is that warming can be structured around a universal biological principle. And rather than a rigid assumption that every vitrification kit must always be worn only with the same media brand. Universality also is strongly supported by the work of a lot of people, as I said before. In general, this is not a single isolated paper. It's a validation pathway developed over several years and across different cell types and clinical scenarios. This matrix summarizes the practical meaning of Lodovico's validation pathway. As you can see, we tend to prepare cases from the previous day. We try to minimize what needs to be done during the process, meaning all other steps except the warming itself or the vitrification itself. We need to carry before, and after warming, we need to follow survival KPIs and ET timings and report the findings. At this point, I want to make an important distinction. Single-step warming or elution has a stronger and more mature evidence base in blastocyst than rapid vitrification as a complete new cohort. Rapid vitrification is attractive because it may reduce exposure to equilibration solutions and improve workflow efficiency during cryopreservation sessions. But the risk profile is much different. Before plunging, rehydration and infrarotational equilibration must be adequate. Therefore, rapid vitrification needs state-specific validation or site-specific embryos, and blastocysts may not behave the same. And my view is that warming simplification can be introduced first and much safer, and while rapid vitrification should follow a more cautious verification pathway depending by cell type and cell states, carriers, and products. This slide describes our implementation model. We did not move directly from reading the literature to routine clinical use. First, we reviewed of course, literature, regulation position, risks, and internal quality requirements. Second, we simulated in events using empty carriers, using the media that was supposed to be used in the worm process. Then we performed preclinical validation where appropriate and feasible using non-transfer materials. Fourth, we ran a control trial with selected cases by senior embryology supervision, and only after that we did move to routine rollout with SOPs updates, competency signed off, and KPI surveillance. The phase was the phase one use is fast protocols require slow governance. Implementation succeeds or fails in the details of the day. We all know that. And before the day starts, cases, as we said, must be selected, median carriers confirmed, inventory checked, responsibilities assigned. At the bench, the workflow should be almost effortless. Pre-labeled, tag this. This is clear timing cues, thermal checkpoints, and fixed time witnessing steps. After warming, survival expansion, and embryo transfer timings and KPI entry must be documented consistently. And at the month end, we reviewed survival trends, deviations, incidents, clinical outcomes, and training needs. A simplified protocol still requires a structured competency pathway. We use a stepwise approach. First, staff observed, then complete control, then the complete protocol performed by a senior biologist, including documentation. Then they perform dry runs with empty carriers, as we said, and then move to the clinical practice. During implementation, we monitor both technical and clinical signals, immediate survival in the primary technical endpoint, but it is not enough. And we also monitor expansion after 1, 3, and 4 hours, 20-hour post-integrity assessment for those cases that we warm blastocysts earlier, 1 day before the transfer for the smaller blastocysts. Our decision rule was simple. Adoption continues only if technical and clinical KPIs remain within predefined control limits compared with our laboratory baseline. This prevents confirmation bias and keeps the innovation inside the quality management system. This is our early local experience. I would like to cite also all this very nice work that Parmigiani and colleagues have done until now in order to support universality and helping people from all around the world implement such fast warming and in the future fast verification protocols easier and help people understand that cryobiology is much simpler than we think. Thank you very much.